Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the full carbon skeleton. The structure is CH3CH or CH, C2H5, CH2O. Writing out all carbons, the C2H5 group contributes to carbons as a branch, ethyl group. The main chain candidates must be identified. Moving on to the next step. Identify the longest carbon chain containing both OH groups. The atoms in the joint chain are C1, CH3, C2, CHO, C3, CH, C2H5, C4, CH2O. That gives a 4-carbon chain with OH at C2 and. Wait, let us re-examine. Moving on to the next step. CH3CH or CH, C2H5, CH2O. The chain drawn has 4 carbons. C1 is equal to CH3, C2 is equal to CH, or C3 is equal to CH, C2H5, C4 is equal to CH2O. The substituent at C3 is an ethyl group, C2H5. And for the final step, check if a longer chain exists by incorporating the ethyl branch. If we include 1 carbon of the ethyl group into the main chain becomes CH2O, CH, or CH, CH2, CH3 with a CH3 branch at C3 giving 5 carbons. But this gives a methyl pentadiol, which is not among the options. Number the 4-carbon chain to give lowest locants to OH groups. Numbering from the CH2O end, C1 is equal to CH2O, C2 is equal to CH, C2H5, C3 is equal to CH, or C4 is equal to CH3. OH groups at C1 and C3, ethyl at C2. Name 2-ethylbutane 1,3-diol. OH at C2 and C4 with ethyl at C3 locant set 2, 4 versus 1, 3. The set 1, 3 is lower, so numbering from CH to OH end is correct. The parent chain is butane, 4 carbons, with OH groups at positions 1 and 3, and an ethyl substituent at position 2. IUPAC name 2-ethylbutane 1,3-diol. A. 3-ethylbutane 2,4-diol, incorrect numbering direction giving higher locants 2, 4. C. 3-ethylbutane 1,3-diol, ethyl at C3 and OH at C1, C3, this misplaces the substituent. D. 2-ethyl 1-methylpropane 1,3-diol, propane parent is only 3 carbons, the longest chain containing both O's is 4 carbons, so butane must be the parent. Therefore, the correct answer is B. Therefore, the correct answer is option B.